All right. I'm not on the Canvas site right now just because of Wi-Fi issues. But you do, if you check your syllabus, your test 4, which is actually, test 4 is going to be next Wednesday, which is, what is that? I think that's the 21st. Let me just check. Yeah, next Wednesday, the 21st. And that'll be over chapters 7 and 8. So I'll get together. I actually don't have a practice test done for that yet. So I'll have to get a practice test together and put it up for you. At this point in time, before I proceed, were there any questions over 8.1 or 8.2? If so, please feel free to ask. Okay. Now, as usual, the Monday before Wednesday's test will be review day. So we'll go over the practice test on Monday. And then should you have any homework related questions or any other questions related to material, Monday's a good day to ask. And of course, you can always email me before the test on Tuesday or something like that if you want. All right, so we are now in section 8.3. Get up to the smart board. And actually, I'm going to see if I can move my computer closer to the smart board here. Yeah, my little folding table. Is that working? I think that's working. All right. So we are in chapter 8 now, section 8.3. Just back in chapter 7, we did a confidence interval for a proportion. So here in 8.3, we're doing a hypothesis test for a proportion. And so the first thing you do, you establish your null and alternate hypothesis. There we go. Your null hypothesis H sub 0 is that your proportion, population proportion P equals some number, which they call in your textbook K, right? Your alternate hypothesis is that P is either less than, greater than, or not equal to K. So it's either a left tail, right tail, or a two-tail test, right? In that order that I wrote it. Any questions on that? That's like what we did in 8.1 and 8.2. We established the null and alternate hypothesis. Step 2, determine the level of significance alpha. Again, that will be given to you in your problems. And then we're going to do this. I set this up strictly on the TI calculator, so I don't go over the critical region method, but I do want to show this. We already know how to change a z value or an x bar value to a z value given sigma for the population or given s, right? So what we've seen if you're given sigma, you're changing x bar to z by doing x bar minus mu divided by z over the square root of n, right? If you don't know sigma, but you know the sample standard deviation, we use a t-distribution. We change the x bar value to a t value. Okay, so I'm doing this on purpose to show you a pattern, by the way, because I mentioned this earlier. Your ability to standardize, in our case, an x bar value, and then either use a table essentially is what it's for, is imperative when you're doing hypothesis tests. And the pattern is you take your sample statistic x bar, you subtract the population statistic, or the population parameter, which corresponds to it, which in this case is mu, and you divide by the standard deviation, right? For both of these, you're dividing by the standard deviation of either the population or the sample for the x bar distribution. It's a similar pattern when you're doing proportions. Oh, and by the way, I gotta tell you, your calculator, your graphing calculator, when you, for example, if you're using a t-distribution and you enter x bar and mu and s and the sample size, all of this stuff is calculated on your calculator. And let's say it's a right tail test. That observed sample statistic is like this thing right here, whatever your t-value is that's observed. And then the area in the tail beyond that, that's your p-value. P is the area in the tail beyond the observed test statistic, if you'll remember. So when you enter all of this needed necessary information, either for this or for this on your calculator, it automatically goes through, calculates this, and calculates the area in the tail beyond that value, all right? And that's that p-value that we then look at on your calculator and compare it to alpha and decide, do we reject or not reject a null hypothesis, right? All right, that's said and oops, there we go, that's said and done. The delay tricks me sometimes. Here we go. So what we're doing in this section, now your calculator is going to do this for you, right? So you're gonna have a certain proportion under P under a null hypothesis, as you can see from step 1. And then technically what's going on is you're finding something called P hat, which we talked about in chapter 7. And that's your number of successes R divided by your sample size N. And your calculator, again, we ran into this. Your calculator doesn't call it R, it calls it X. Just be aware of that when you do this on the calculator, all right? And so the idea is, so check this out. You take your sample statistic, you subtract the corresponding population parameter, and you divide by the standard deviation. And for this, for proportions, the standard deviation is the square root of P times Q over N. Now, all of this is going to be done inside of your calculator, right? And the only, and yeah, at any rate, so what are we doing here? So anyway, we're going to plug in the necessary information. Your calculator is going to calculate that, and then from that get a value, some kind of observed value, beyond which is your p-value, which we're then going to look at and decide to reject or not reject a null hypothesis. Any questions on that? All that's behind the scenes, so to speak. But I wanted you to see this pattern because it's true with a lot of different confidence intervals and tests. The idea is, again, you take your sample statistic minus the corresponding population parameter and divide by the standard deviation, and that gives you your observed sample statistic, or your observed z value or t value for that matter. All right. So that's what we're going to do here. And then on the TI graphing calculator, I'm gonna pick a problem. Actually, I'm gonna pick 2 problems to do for you as an example. And then we'll let it do the plugging and chugging, and we'll take a look at the p-value and decide whether to reject or not reject the null hypothesis. All right. Any questions on that? So you got a good life when you have a graphing calculator in statistics. All right, so let me pick a problem. Actually, like I said, we're going to do 2 of them, but I want to do a single tail, and I also want to do a 2-tail for you. And I can't see the text. Hold on just a second. I'm afraid to turn on too many lights because I think it's going to upset my Wi-Fi. This is on page 476. And it's problem number 10. I gave you for homework problems, what is it? Problems 9 and 11, right? So we're going to take a look at problem 10. Page 476. Do I need to wait for anybody that might be trying to find that, by the way? I don't know that I've ever asked that before, but I should have. All right. This is concerning graduation rate. Women athletes at the University of Colorado Boulder have a long-term graduation rate of 67%. Over the past several years, a random sample of 38 women athletes, so N is 38. Random sample of 38 athletes at the school showed that 21 eventually graduated, a number of successes. Again, which on our calculator is going to be X instead of R. Does this indicate that the population proportion of women athletes who graduate from the University of Colorado Boulder is now less than 67%? Use a 5% level of significance. All right. I'm kind of, yeah, hold on just a sec. I want to pop up my little Algebra calculator here. Well, if it comes up, here we go. Let's take a look at this. 21 divided by 38 is going to be less than 0.67, but let's check it to see. It's 0.55, okay? So based on that sample, it's about 55%, right? So under our null hypothesis, in fact, give me just a second so I can write this over here. Under our null hypothesis, which is always a hypothesis containing equality, right? Our proportion of successes is 67%, my voice was changing, 0.67, okay? And what we're interested in is, based on the sample, is it significantly less than that? Because it's 0.55, it's less, but is it significant, right? So our alternate hypothesis is going to be that the proportion is actually less than 0.67. Any questions on that? All right. Now to do this, again, because of Wi-Fi issues, I'm going to stop share and I'm just going to share my graphing calculator. So give me just a minute. Screen, graphing calculator, blam, here we go. Well, there we go. You should be seeing a graphing calculator up there now. So we are going to press the stat key. We're going to go to test. And what we're doing is a one proportion z-test. That's number 5. One prop z-test. I'm just going to press the number 5 rather than arrow down. Oh, I thought I was going to press it. Try it again. There we go. All right. And I've already entered data because I wanted to make sure my calculator was running all right. Under the null hypothesis, P is 0.67. So you'll enter 0.67. The X value, which we call the R value, is 21. Sample size is 38. So you'll enter these, you'll type it in and press enter, right? You'll come down here and we're doing a left tail test. You'll select the left tail test and press enter. And then we'll calculate it. Do I need to wait for anybody that's actually physically doing this? Okay. All right, let's take a look. Yeah, see that P hat, the fourth one or third one down, third line down. That's that 0.55. That's the R over N that we calculated. All right. So let me again I'm going to write this down before I share the screen. So we end up with P. Let's say 0.06. All right. So we got that. Now I'm going to stop share. All right, so now I'm sharing the screen again. So I went on and wrote P equals 0.06. That's my P value. And I should say, you know what? I should say P value. Let me say PV. All right, so we don't get it confused with this P right here. My P value is 0.06. We compare it to alpha. 0.06 is greater than 0.05, right? In other words, my P value is greater than my alpha value. So we do not reject the null hypothesis. I'm just going to say, so you write something like based on this sample, don't reject the null hypothesis. And I'm going to write it like this, right? Don't reject H sub 0. Based on this sample, the graduation rate is not significantly less than 67%, something along those lines. Any questions on that? So that is that's a left tail test. Of course, a right tail test is just going in different directions. Let's take a look at a two tail test. By the way, do I need to wait before I erase this board? Okay. So I want a two tail test. We're going to, let's see, yeah. We're going to take a look here at problem number 12 out of the section. So it's still on page 476. All right. Preference color. What is your favorite color? A large survey of countries, including the United States, China, Russia, France, Turkey, Kenya, and others, indicate that most people prefer the color blue. In fact, about 24% of the population claim blue as their favorite color. This was an actual study done, and they make a reference to it. Suppose a random sample of 56 college students were surveyed, and 12 of them, R equals 12 of them, said that their favorite color is blue. Does this information imply that the color preference of all college students is different either way than that of the general population? Use alpha of 0.05. So here we're doing different either way, right? And what did I just tell you that was? 20, all right, 24% is what they theorize that it's equal to. So we'll say that our null hypothesis is that the proportion is 24% based on that international study that was done, right? Then they took students at a particular college. So we want to know, is the proportion not equal to 0.24, which means either way, right? Any questions on that? All right, again, bear with me because I need to change the share so I don't freeze up. There we go. So you should be seeing the graphing calculator now. So again, we're going to go into stat tests number 5. This time under the null hypothesis, our proportion is point, what is it, 24. Our value for R, or X in this case, is 12. There were 12 people that preferred blue out of 56 people. This time we're doing, where it's the tail of the test, we're doing the first one, not equal to. So I'll press enter and select that, and then we'll calculate. And what do we, whoa, that's huge. Let me make sure I entered that right. That is a big p-value, 0.64. Maybe I did enter it right, and it's just that big. Under the null hypothesis, 0.24. X is 12, N is 56. Well, it looks like that's what it is. Calculate it. All right, let me stop sharing that after I write my p-value down. Um, 0.65. Okay, so stop share. Oops, maybe I better clear that first. All right, stop share. All right, now, yeah, let me wait for that little thing to go back up there. Come on. All right, take a look at that p-value. That is incredibly huge. There are no alpha values that anybody uses where you're going to reject a null hypothesis with a p-value of 0.65. Okay. So 0.65, my p-value is bigger than 0.05, so we don't reject the null hypothesis, bottom line. Any questions on that one? All right. Do I need to wait for anybody before we take a look at 8.4? All right. Here we go. More. Testing paired differences. Now check this out. 8.4, we're testing paired differences for what are called dependent samples. We're testing paired data, like before and after data. Like you're taking somebody's blood pressure, then you give them some medication, and then you take it again to see if that medication has lowered their blood pressure or something along those lines, right? In 8.5, we're going to look at that Friday. We're going to test differences of independent samples. All right, so the test will be slightly different. So we're assuming for 8.4, dependent samples. The same object is being measured before and after a treatment. And that test requires, if you're doing this by, well, if you're doing it by hand, that the mean of the paired differences in this order, before minus after, is known as D bar. Okay. So you find the averages of the before, the average of the after, and then you find the average of the before minus after. Under the null hypothesis, the mean of those differences is 0. See if this makes sense. We're assuming under the null hypothesis that the mean for before equals the mean for after, which means if you subtract A from both sides, B minus A, that's going to equal 0. And that B minus A is what we're calling D bar, the before minus after mean, right? So that's why there's a 0 here. So essentially what we're testing is, for an alternate hypothesis, is the mean of your differences not equal to 0? Is it a 2-tailed test? Is it greater than 0, or is it less than 0? Okay. By the way, what we're doing here, your calculator is going to do this for you, but I want to show you this. We're going to be using it. Well, we're using a t-distribution, but again, your calculator, like I said, is going to do this for you. They're going to take that D bar and subtract the mean of your population mean of distance, differences, excuse me. So you have your sample statistic minus your population parameter divided by the standard deviation. So that's the standard deviation of your D values over the square root of n. Your calculator is going to do this for you. That's going to give us our p-value. And again, let's assume here we're looking at a t-distribution, but the mean is still 0. So you have some kind of a t-observed, let's say it's up here. It's going to calculate this area in the tail, which we will then compare to the alpha value to make our decision, right? That same pattern just keeps popping up. Now this is a little bit more involved on your graphing calculator. So let me actually find a problem here. What did I give you? Let me check. I gave you 9 and 11 here too. Let's do, let's do problem 10, and it's on page 489. Page 489, number 10. So I'm going to get closer to the computer so I can read this to you. It's testing to see whether fishing is better from boat or from shore. Pyramid Lake is located on the Paiute Indian Reservation in Nevada. Presidents, movie stars, and people who just want to catch fish go to Pyramid Lake for really large cutthroat trout. Let row B represent the hours per fish caught fishing from shore. Let row A represent hours per fish caught from using a boat. And then use a 1% level of significance to test to see if there's a difference either way in the population mean hours per fish caught using a boat compared with fishing from the shore. So give me just a little time here. So what they have is a table here, and before is the shore, and it's over months from October through April. I guess that's during the fishing season. So I'm not going to do all of these, but I'm going to do them when I type them in. So like they start out here in October, and from the shore, the average time spent was 1.6 hours, and from a boat it was 1.5 hours. And then they go all the way down to April. And from a shore, it was 3.3 hours. And from a boat, 3.8. Right. So I'm going to share my graphing calculator, and we're going to type this stuff in. Give me just a minute here to reshare. Stop share, graphing calculator. Okay. There's my calculator. Come on. So there we go. You should be seeing my graphing calculator right now, okay? So here's what we're going to have to do for this. It's before minus after data. We're going to let the calculator calculate before minus after, all right? So we're going to go into stat. Option number, or option 1 is edit. So we're going to press enter. All right, I have data in there already. I'm going to clear it. And I'm going to enter the data that's in your textbook for this problem, all right? So so here's before, it's the shore. So the first one's 1.6. Enter. 1.8. 2.0, I'm just going to enter 2. 3.2. 3.9. 3.6. Okay. And then 3.3. All right. And that's my before information. I'm going to arrow to L2 and enter my after information, which is from the boat. 1.5. 1.4. 1.6. 2.2. 2.2. All right. 3.3. And 3. And 3.8. All right, so I've entered my data in list 1 and list 2, right? Now, we need to find the differences. We're going to let your calculator do it, and here's how. We're going to arrow to the right to list 3, and we're going to highlight the name of the list, L3. And then at the bottom, if you take a look above the numbers 1 and 2 on your calculator, you'll see L1 and L2, right? So we're going to do before minus after, that's going to be second L1, which is 1. So I press second and the number 1, minus, and then second and the number 2. So that's going to give me list 1 minus list 2. So when I press enter, blam, there's the differences right there that your calculator's got. Any questions on that? All right. Now this is a sample, so we're using a t-distribution. So let me do second quit. Please, there you go. Now we'll go to stat, tests. And what we're doing here is a t-test. Item number 2. I'm just going to press number 2. All right. Now, usually we've input stats where it already calculated stuff for us. The calculator's got to do this. So we're going to arrow to the left and highlight data and press enter. Under the null hypothesis for these before and after differences, the mean is 0. Now check this out. I put everything in list 3. So for list, I have to press second. Oops, and I didn't do it. Second and the number 3. So that you can put list 3 in there. For frequency, you want 1. And what we're doing here is it different either way? So it's two-tailed. And then we'll calculate. And let's see what do we get. 0.08. That's big. We're not going to, in other words, there's not going to be a difference at the 5% level, right? So let me stop sharing and write that down. So P is 0.08. Okay. Minimum. Okay. under our null hypothesis. The mean of the differences equals 0. Under our alternate hypothesis, it was two-tail, not equal to 0. We found the p-value to be 0.08. The level of significance they wanted here was 1%. So obviously the p-value is bigger, right? Don't reject the null hypothesis. Based on this sample, there's no significant difference between before and after, between fishing from the shore or fishing on a boat at this particular lake, right? Any questions on that? All righty then. So like I said, Friday, we're going to look at one more section in chapter 8. Monday, we're going to review for the test. Wednesday, you're going to take your test on chapter 7 and 8. Have a good day and be safe out there, folks.
Thank you.
Thank you. Thanks.